Okay, this is your old instructor, CNC dude Ed here. We're going to improve our Titan 2M project by running better feeds and speeds. If you watch some of the videos I made on feed and speeds, talking about chip load per tooth and how many RPM you're going to run. So if you start watching many videos, Titan Lab videos with demonstrations, and he puts right up there RPM, surface feet per minute, chip load. So all these are calculations. You know, initially he trains you with putting 4,000 on everything. So, but we can be more accurate at that and a little more machine specific. Just for a quick review here. In classwork, we got feed and speed lesson right here. And this would be a typical feed and speed chart. A lot of companies have these, so I probably should highlight this area right here. But if we're pretty much cutting aluminum, and later on we're going to do some low carbon steel. So right here is surface feet per minute. Now if you watch the Haas Tips video on the tractor with the big tires and little tires, that's what we're all talking about here. This is this is not RPM, this is how you get RPM. The high and the low limit recommended, and it's a good starting point. There are other notes down here, like when using long or extra long end mills, reduce feed per tooth by 50%. If you're using coated ones, you can actually increase the speed, which is RPM. So there's some notes there. But generally speaking, your normal milling operations, right here, this is a good starting point. So you need to have RPM before you can start figuring out the feed rates. In order to calculate surface feet per minute, it's a formula, but in Fusion it's built in. So if I go into, let's try the half-inch end mill, right? Half-inch end mill. That's this half-inch end mill. So right here it says feet per minute. Looking at the chart, 600 to 1200. I want to go as fast as I can, but not too fast. Here's my Fusion again. Okay, 1200. 1, 2, all right. That comes out to 9,167, which our fastest machine only goes 8,100, so it can't get there. Let me try 1,000. That's 7,639. That's capable of doing that. It's actually a formula called surface feet per minute times the constant 3.82 and divided by the diameter. So you're going to have the small end mills will have to run as fast as the big end mills to be able to like cover the same amount of ground if you were to lay it out flat. So actually you got to turn the small tools faster, and then face mills you got to turn them slower. So this is 706. So this is, we can attain that speed, and this is totally safe. Now what about cutting feed rate? That's inches per minute. That's where this comes in. End mill feed per tooth in inches. And they give you 3 ranges here. Up to 1/4 inch, which is 0.250, up to 1/2 inch. I would say that'd be 0.250 to 0.5, and then when you get above 0.500 is a different range. So if you're using the typical 3/8 or 1/2 inch Titan end mill, they say 0.002 to 0.004 is good. Let's go with the, so it doesn't really matter RPM because it's going to be based, You need the RPM setting in order to do this. And once you change RPM and base it on chip load, your feed rates will automatically increase in your settings. Let's pick the 2000s, right? All right. So we got the RPM set, and right here it says feed per tooth, 0.002. That is 45 inches a minute. And if he's been telling you 20, this should be twice as fast, right? Well, in this case, these RPMs, this feed rates didn't change and that one didn't change. So we're going to make some alterations here. But this is like a starting point of why do we want to do this, because we're basing it on some data here. We need to use some data. Now, if we're using low carbon steel, the surface feet per minute goes down, but the feed rate per tooth is really kind of the same, sort of. They're always in small numbers, thousands. And if you have more teeth, that means you can go cut more per revolution. So we can get into that. It's got math. So, but I made an updated tool list, and I'm going to update that right now. I'm going to go to edit these tools. All right, so it says select. I'm going to go, I have the STC Titan building blocks right here. I'm going to go into here, and this is my current operation, but this is my STC Titan building block. And if I use the milling one, I can narrow it down, smaller list. And these are sorted by size. So right there's 3-inch. And we have a 5. We actually don't use the Kennametal face mill. We're using a 5-flute Miltech. So I'm going to select that. Because in here I already set them up to be machine specific. And this will help you out. So right now it says, right here it says preset, default, preset. And it puts all these things in here. So notice the feed per tooth is 2,000 and change. 50. These are like 30 inches a minute, 2,500. So these would all work. What if we pick this one? It says right here, this is our two machines, TM1P. Press that, and these are all ready to go. 3,183. 35 inches a minute, that would work. If you're in the VF2, 3819, this would be fine. So I'm going to just plug these in for the VF2. All right. Let's actually also, before I get too deep into it, machining time. Machining time here says 6 minutes and 36 seconds. I think it actually already improved this one once, but if I look at another one here, like this one, I put RPM on this one. All right, and there's this one here, right? And I do machining time. Yeah, this is 8 minutes and 54 seconds. So that would be like 2 minutes faster. So if I was making 100 parts, that would be 200 minutes of saved time, which is about 2.5 hours you would save. So 2 minutes per part is actually pretty substantial. Okay, let's go to adaptive, edit. I'm going to go into the new tool library. I'm going to go find my tool, milling, and that's the 1/2 inch one right here, 1/2 inch. Select. Default preset is already on 4,000. Or I'm going VF2, 7,500 RPM, 56 inches a minute. This should work just fine. All right, every time you change something, it says toolpath out of date, so we'll have to regenerate those. Let's look at some other settings of improvement. Model top passes. Optimal load is 75 thousandths. That's the sideways cut. I would leave that alone. You might have to touch that one. And this one here, lift height, 0.01. And I'm going to change the non-engagement feed rate to 400 inches a minute. And then if I want these to always be there for adaptive, I can just go in here and say make default. So every time I bring this up, it'll already be there. And I'm going to leave this stay down level at 70%. Helix angle, this all looks good, right? All right. Close this up and hit OK, right? It's recalculating, okay. All right, I noticed this one is on cutting on 2 levels. So I had done some screenshots of settings, and I noticed that one of them was this number here, maximum roughing step down. We want to make this bigger than the tallest part of this thing, so we're just going to put in like 0.8. All right, I'm going to hit OK. All right, recalculates. All right, now we only have one outside cut. It doesn't need to go around twice. This should work just fine. All right, let's go to 2D contour, which is the same tool, but we haven't set the preset. So we're going to save this. This is going to be, oh, this one's not set. We got to go get the tool, that's why. Get the tool, but I'm using the same tool. So I'm going to go into operation 1 right here. Why do I have 2 here? Yeah. I'm sorry, I got 2 tools on. That's why I'm getting messed up here. Cancel. Let me simplify this. I want to get rid of that. Ooh. Okay, go back to this one. Aha, I changed the wrong one. Do not leave it open. All right, we got the custom. Oh, there you go. So reselect this tool. Reselect this tool. Op 1. So I got to go in here and get the new tool. 1/2 inch end mill. Select and change this to VF2. And then go down and change this to roughing max step 0.8 or 1 inch would work. And I'm going to change this to 70%. Lift height of 0.01, and I'm going to change this to 400 inches a minute. Not engagement feed rate. Hit OK. Okay, recalculates, and this will do a full depth cut. All right, all the way around. Okay, let's go to the next tool. Edit. So we got to go select that tool, which is really in Op 1 already. So Op 1. Notice we have two tool 2s. We have duplication now. Which one is which? One of them has presets, one of them does not. Let's select the bottom one. Ah, that one's got it. All right, VF2. Done, and this is contour milling, so we don't have to change any of these other numbers. Wear compensation. Okay, that one's done. And go up to here. Edit. I got no custom settings. That means I got to go get the other tool in operation 1. Or I can just go right into the Titan, STC Titan. I think that will get me what I want. Notice down here it says cutting data, TM1 VF2. So if I was up here and pick this one, see this one only has nothing and this one's got both. Either one will work. I'm going to change this one to VF2. That one's done. That's contouring. That one's done. We have chamfer mill. Edit. Select. Go into the STC library. That was the 3/8 chamfer mill. This one here. This has the presets. Okay, select. And I'll make this VF2. That's 8,000 RPM. That will work. Hit OK. And then we get drill, deep drilling tip. So this one uses the same chamfer tool. So I'm going to have to go get that. Select up 1, and right here, 14. Select. I'm going to leave this at default setting at the lower RPM for the drilling, because this is doing two different things. So I don't think we can improve that at the moment. So we'll leave all those numbers the same. Okay. All right, this one is the drill, and so these we can leave alone. Hit cancel. So now we have to renumber the tools because they're not in order. So I go to here, tool library, operation 1. 1, 2, 3, 4, 5, 6. I get 6 tools. Is that correct? Spot drill, chamfer mill. We have 2 of them. Ah, I got the wrong selection here. I should only have, let's see, select tool, up 1, 14, this one right here. Select. And leave it on default. Hit OK. Alright, I go to Tool Manager, Operation 1. I got 5 tools. I'm going to renumber them. It's going to be by order of operation. Renumber. The following are using feeds and speed, but yes, they've been edited, correct. Okay, I think one other thing we can check. Oh, wait a minute, this has got different tap, different feed. I think I was doing, I don't know what I was doing there. STC, I gotta go get the proper drill, which would be 228 drill, close. That would be tool 4. Edit, select, op 1. So I gotta go in here. And if I do hole making, it'll narrow my selection down to 228. Hit select. And we'll leave this alone. So another improvement in this one could be, right here it says pecking depth. So Mark Terryberry said we can do 1 to 2 times the diameter. So the diameter is 228. I'm going to make that 0.2. All right. And then the tap, let's got to go get the proper tap. Edit, select. I'm just going to go back in the library to make sure I have everything selected correctly. That's this one here, the 1/4 right hand tap. Select. Hit OK. Then go in the library. Now, I have 1, 2, yeah, now I get them all selected correctly. I'm going to do 1, renumber these. Yes, hit yes there. Yeah, yes there. Yes there. Okay. 1, 2, 3, 4, 5. That's correct now. Close. Let's do a quick time study. So this is now 5 minutes and 13 seconds versus 8 minutes. Close. Quick simulate. All right. Play. Now it's not going to run any faster in the simulation, but we'll make sure we selected everything correctly. So this is that trochoidal toolpath. This is the optimal load, how much it steps over. And you can see over here it's staying away from the boundaries. That's your stock to leave setting. And I have the operations set for it changes colors per operation. You might be using the same tool, but you can identify which one's doing what. All right, now I think it changes operations in a minute here. Yeah, it becomes another color. Okay, this is your finish cut. Okay. Now we're going to, oop, that looks a little deep. Why is it so deep there? It would work. I think I must have a setting off. I think this should be closer. Chamfering looks fine. Done. Okay. Let me go revisit this one. I was looking at this. This looks like it's on the right level. Oh, you know what? Contours. Not that one, but this one. Notice this looks low. I think I picked the wrong number there. It's below that surface. I made a mistake. Edit. Heights. Usually you have to do with the heights. This says selection. What did I select? I selected that surface. It says face. Let's see. This is nothing. This is that one, right? So this should say minus 400. Yeah, that looks right. Okay. Okay. Now that looks correct. See how these lines are up above? Oh, okay. Let's just do a quick simulate, right? I'm going to jump ahead by operation. Operation 1, operation 2. Now we'll hit play. Oh, I'm sorry. 3, and now we'll hit play. No, it's still got those lines there. All right, let's look at the adaptive settings. Now it looks high. Okay. What do we have here? Geometry. Rest machine.
You have 15 minutes left of computer time.
Heights. Well, yeah, that's okay. Stock to leave 20 and 20. Find step down 800. Use slot clearing machine cavities. Machine shallow areas. Maybe that's it. Hit OK. I think maybe that looks better. So this is where I'm going to take some screenshots. Simulate. Jump ahead. Jump ahead. Jump ahead. Hit play. Yeah, that's it. You got to add machine shallow areas. It would have worked. Okay, let's check the time study. Is still the same time, 5 minutes and 13 seconds. Okay, this is ready to go. Let me check my setups here. Stock up here. I need to make sure I fill this out. So 1001 is going to be our operation 1 standard number. This will be Titan 2M. Op 1 and EFD, my initials. Leave this on 0. Why did it do that? Oh, this is tilted, that's why. I must have imported this one. Alright, so that's all set to go. Let's make some code. I have name here, program numbers done, Haas mill done, post. Put it in the USB and double check the code, right? You have program number, program name, machine, timestamp, list of tools, 1, 2, 3, 4, 5, and we got 3820 for RPM. This one's 7500 with the better feed rates. The F is the feed rate right there. So this is ready to go. All right, and I'll follow up with the video on operation 2. This is our feed and speed update.